Hi, today we're looking at Functional Skills Maths Level 1. We've got the AQA exam board, we've got the February 2023 paper, and we're going to start with the non-calculator section. Question 1. Work out minus 12 minus 17. Okay, and they've given us some options to choose from. So we're starting in a minus 12, so if we've got a number line, say 0's here, minus 12 is going to be somewhere down here, and we're minusing 17, so we're going to be going down to the left. So we don't even have to work out what the exact answer is. We can straight away see it can't be minus 5, because minus 5 would be up here somewhere, so it can't be that one. It can't be positive 5, because that would be up here somewhere. Minus 29 could be, because it's going to be more negative than minus 12 or negative 12. 29, well again, that's going to be up here somewhere. So, minus 29 it is. Question 2. Write the number 256701 in words. Well, I'm going to put a comma in first of all, so start from the back and we'll count 1, 2, 3. Now it makes it easier for me to read it. So now we've got 256,701. So we just need to write that all in words. So 256,000, comma, to show where the comma is, and then we've got 701. 701. Okay, question 3. Work out 0.3 times 0.6. Well, I'm going to ignore the 0 points and I'm just going to say, well, 3 times 6. Well, that's going to be 3 times 6, we're going to have 6, 12, 18. But we've got one decimal place here and another decimal place here, so that's 2 decimal places. So if we imagine a decimal point starting at the end, we've got to move it 1, 2 places. So we end up with 0.18. Well, that's going to be 0.18. Question 4. Draw all the lines of symmetry on this equilateral triangle. Okay, so I'm going to get my ruler for this one. Well, if it's an equilateral triangle, it means that all the sides and all the angles are the same. Well, I can see straight away that I can chop it straight down the middle here. One line of symmetry. Now, because it's an equilateral triangle, it means we're going to have the same sort of thing going down this way as well. In fact, if it's not clear, what you can do is you can rotate the page. So, for example, if we have, now we've got, this is the base of the triangle, you should be able to see we can do the same thing going down through here. Okay. And also, we can now cut it through this way. So then let's turn it around. So now this is our base of the triangle. So each time we're just cutting it in half left to right, but we're rotating the triangle into all the different options that we've got. Okay, so we've drawn 3 lines straight through the middle that split the shape into 2 equal parts that are kind of a reflection of each other. Okay. So that was question 4. Question 5. Work out 35 plus 4 minus 7 minus 12. Now we need to do whatever's in the brackets first. So this 35 plus 4, or 5 plus 4 is 9, 3 plus nothing is 3. So all of that in the brackets becomes 39. We need to do the same with this bit in this bracket. So we've just got 7 minus 2. Well, we can write it as a column. 7 minus 2, so count back 2 from 7, we'll have 6, 5. So we've got 5 replacing this bracket here. So we've now got 39 minus 5. Well, let's just count 5 back from 39. So we'd have 38, 37, 36, 35, 34. And we can put that on our answer line. Question 6. Work out 5/8 or 5/8 times 24. Right, so we've got an option of how we do this. We can multiply the 5 by the 24 and then divide by 8. Or we can think of this as 24 divided by 8, so an eighth of 24, and then multiply it by the 5. Which way should we do it? I'm going to do the 5 times 24 over 8. Okay, it's the same thing. So we're doing the multiply first and then the division separately. So 5 times 24 over 8, or 24 divided by 8. Well, think of the 8 times table. You've got 8, 16, 24. So that's 3. So in other words, what we're saying is 5 times 3. And 5 threes, we've got 3, 6, 9, 12, 15. Now, if we did it the other way, or we could say, well, it's 5 times 24, and then all of that divided by 8. Now, if we do that 5 times 24, let's do it here. We'd have 5 times 4, 4, 8, 12, 16, 20. And 5 times 2, or 2 times 5 is 10, and 2 is 12. So we'd then have 120. So this is like my optional bit. So we'd have 120 divided by 8, which if we do that in the bus stop method, we'd say 8 doesn't go into 1. 8 goes into 12 once, remainder 4. And 8 goes into 40. 8, 16, 24, 32, 40. That's 5 times. So either way, we're going to get an answer of 15. But it's up to you if you want to do the multiplication first or do the division first. Now, I know you're going to say, oh, but big maths rules, we should always be doing division before multiplication. When you've only got division and multiplication like this, the order doesn't matter, as you'll see from the fact that you get the same answer. Question 7. Festival. Emily is going to a festival in Wickslow. 7a. Tickets for the festival are for sale on these websites. We've got Tickets Direct. Tickets are £28 per day. There's a special offer. Buy 2 days, get second day half price. And we've got A to Z tickets. Tickets were £26 per day. Special offer, they're now reduced by 20%. Emily wants to buy tickets for herself for 2 days. Which website should she use to get the cheaper tickets? Tickets Direct or A to Z tickets? You must show you're working. Okay, it's just for herself. So £28 per day. And we've got 2 days, so it's going to be 28 plus 28. So 8 plus 8 is 16. So carry 1. 2 plus 2 is 4, plus 1 is 5. So we've got £56. But buy 2 days, get the second day half price. Okay, so we're going to save, so instead of £28, it's half price, so we're going to have 28 divided by 2, which we can do with the bus stop method, like this. 2 goes into 2 once, 2 goes into 8, 2, 4, 6, 8. That's 4 times. Okay, so instead of 28 plus 28, actually what we're saying is, well, it should be 28 plus 14. So we get 8 plus 4 is 12. 2 plus 1 is 3, plus another 1 is 4. So for Tickets Direct, we get £42. Right, now let's work out a price for A to Z tickets. They were £26 per day. Special offer now reduced by 20%. Well, it's still 26 per day, so we're still going to need 26 and another 26. So 6 plus 6 is 12. 2 plus 2 is 4, plus the 1 is 5. So £52, but they're reduced by 20%. So we want 20%, or 20 out of 100, of 52. Okay, or you can think, well, 10% of 52, I'm just going to bring the decimal point in one, so it would be £5.20. So if I want 20%, well, it's going to be two lots of that. So it's going to be £5.20 times 2. So let's move this one up. Okay, £5.20 times 2, or actually we can think of it as £5.20 plus another £5.20. 0 plus 0 is 0, 2 plus 2 is 4, bring down the decimal point, 5 plus 5 is 10. This is the discount. So we want to take our original £52 and take off £10.40. Now, because we're taking it off, what we can do is put 0.00, so we've got something to take these numbers away from. Well, 0 minus 0 is still 0. 0 minus 4, we can't take 4 away from nothing, so we reduce this 2 to a 1 and make that a 10. Now we've got 10 minus 4 is 6, bring down the decimal point. 1 minus 0 is still 1. 5 minus 1 is 4. So A to Z tickets, this price is £41.60. So which website should she use? Well, this one's cheaper, so we can say A to Z tickets, and we can put £41.60 is less than £42. 7B. Emily is going to get the train from Hanston Station to Wickslow Station. Here are the train times. So we've got leaves Hanston Station at these times and arrives at Wickslow Station at these times. Emily wants to get to the festival by 10 a.m. Emily wants, so we said that, she needs to leave home at least 7 minutes before the train leaves. It takes 12 minutes to get from Wickslow Station to the festival. What is the latest time Emily can leave home? Right, okay, so we've got to do some working back from this one, really. So it takes her 12 minutes to get from Wickslow Station to the festival. So she needs to be there by 10 a.m. The latest she can arrive at the station is 10 a.m. minus 12 minutes. Okay. Right, now what we've got to do here is we've got to be careful because this is in hours. So we haven't got hundreds that we're working with, but actually we've got 60 minutes. So we want 60 minus 12. So 0 minus 2 we can't do. So reduce that to a 5 and make that a 10. So 10 minus 2 is 8. 5 minus 1 is 4. So this is going to be 48. Because we've gone back an hour, it's going to be one less than 10. So it's going to be 9:48 a.m. So that's the latest can arrive at Wickslow. Okay, so if it's the 9:48, well, she can't catch this train because that would be too late, the 9:50. So we can rule that one out. So really, if we want the latest time she can leave, well then she's going to need to be on this train. Okay. But what we're trying to find is the latest time she can leave home. Right, so we've dealt with the 12 minutes already here. She needs to leave home at least 7 minutes before the train leaves. Well, it's leaving at 8:56. So we need 7 minutes before that. So minus 0.7 minutes. Well, 6 minus 7 we can't do because 7 is bigger than 6. Make that a 4 and then a 1. So we've got 16 minus 7, which is 9. 4 minus 0, which is 4. And we've still got the 8 there. So our answer is 8:49 a.m. And we can put that on our answer line here. Question 7c. Emily meets up with some friends at the festival. Emily and her friends each buy some food. Here are the amounts each person spends on food. So one spent £16, one spent £24, and so on. Emily says, on average, we each spent £22 on food. Is Emily correct? You must show your working. Well, because this is a level 1 paper, we know that when we're talking about average, we must mean the mean. Oh, mean, not meme. And the mean is calculated as the total divided by the frequency, or how many we've got. So the total, we're going to need to add these all up. So we're going to have 16, 24, 27, 17, 23 and 19. 6 and 4 is 10, plus 7 is 17. I'm going to cheat and add the 3 to make it 20. 27 and 9 is going to be 36. Then 1 plus 2 is 3, plus 2 is 5, 6, 7, 8, 9, add the 3 is going to be 12. So we've got £126 in total. And how many have we got? 1, 2, 3, 4, 5, 6. So we want 126 divided by 6, which looks like this if we use the bus stop method. 6 doesn't go into 1, but 6 goes into 12. 6, 12, that's twice. And 6 goes into 6 once. So we get an answer of £21. Well, £21 is not equal to £22. So is Emily correct? No, she's not. And that's the end of the non-calculator section. So now we're going to look at the calculator section. A fair ordinary dice is rolled. Circle the probability of rolling the number 4. Okay, well, ordinary dice, we've got the numbers 1 to 6. So there's 6 possible outcomes. There's only one number 4, so it's going to be 1/6. Question 2. Convert 2,460 centimetres to metres. Well, I know we've got 100 centimetres in 1 metre, so that means we want to divide this by 100. Because if we go into metres, there's going to be fewer of them, so we need to make it smaller, so we're going to divide. And to make it smaller, we think we've got the decimal point here at the end. We're going to move it twice, once for each 0, that way to make the number smaller. So we're going to end up with 24.6. If you want to put 24.60, that's fine. It's not wrong, but you don't need to have the 0 once it's after a decimal point. Question 3. You are facing northeast. You turn clockwise to face southeast. Write down the angle of turn. All right, let's do a quick sketch. Well, if that's north, we've got never eat shredded wheat. So we're facing northeast, so that's going to be in that direction. And we're turning clockwise, that's this way around, to face southeast, which will be in here. So we want this angle, and actually hopefully you'll see that's a right angle there. And if it's a right angle, it's going to have to be 90 degrees. Question 4. Work out 76 squared minus 47 squared. Okay, so, well actually let's do them separately. Well, 76 squared means 76 times 76. So we can take the calculator for this. 5,776, and we'll do the same with 47 squared. So that's going to be 47 times 47. Which is 2,209. So they want 5,776 minus 2,209. And we get 3,567. Which we can write on our answer line. Question 5. Write these fractions in order of size, starting with the largest. Okay, so we could work out a common denominator for them all, but actually this is in the calculator section. So we can say, I'm just going to work them out as decimals. So 2 divided by 3. Well, this is 0.6666 recurring. 3 divided by 5, 0.6. And 5 divided by 8, 0.625. So we want them starting with the largest. Well, they're all 0.6. It's 0.66. So it's got a bigger second digit. So it must be this one first. Biggest. Then, well, this one's bigger than this one because it's 0.62. This is just 0.6. So it's going to be in that order. So that means we start with 2/3. Then we have 5/8. And then 3/5. Question 6. Work out the range of these numbers. Well, the range is the biggest number minus the smallest number. And the biggest number, 26. Yeah, that's the biggest. And the smallest is 9. It's the only single digit number. So we want 26 minus 9. Is 17. Question 7. Here is an L shape. Okay, so we've got some different measurements on here. Work out the area of the L shape. Right, so what we need to do to work this out, we need to split it up into rectangles. So I'm going to draw a line down here. So I've got one rectangle here, and the area is going to be the length, which is 14, times the width, which is 10, times by 10, we just put the 0 on the end, a centimetre squared. Now for this rectangle, the area is going to be the length, 7, times the width, which is 5. And I'm going to use a calculator for this. Or you can, if you think you know what it is, you can get it and then check with the calculator. So 35 centimetres squared. So the total area will be 140 centimetres squared plus 35 centimetres squared, which gives us 175 centimetres squared. And we can put that down here. They've already given us the units. If they haven't, make sure you put it on. Question 8. Building company. 8A. Kim works as a tiler for a building company. She is paid a normal hourly rate of £26.50 from Monday to Friday. She is paid double the normal hourly rate on Saturday. She does not work on Sunday. Here are the hours she worked from Monday to Friday 1 week. So we've got Monday, she worked 6 hours, Tuesday 6 hours, Wednesday 7.5, same on Thursday, and 6 hours on Friday. And we don't know how many hours she worked on Saturday. In total, Kim was paid £1,060 that week. How many hours did she work on Saturday? Right, okay, so to work this out, what we can do is we can work out how much she was paid for Monday to Friday, take that off of this total, find out how much she got paid Saturday, and then use the hourly rate to work out how many hours she worked on Saturday. So that means the first thing we want to do is work out how many hours did she work Monday to Friday. So we've got 6 plus 6 plus 7.5 plus 7.5 plus another 6 gives us 33 hours. And that was all at a rate of £26.50. So that means for Monday to Friday, she earned £874.50. So on Saturday, she must have earned £1,060 minus £874.50. So 1,060 minus 874.50, which gives us £185.50. Okay, so that's the amount she earned. We want to know the number of hours, so divide it by the hourly rate. But actually Saturday, she was paid double the normal hourly rate. So that means double would be 2 lots of £26.50, which would be £53. So if we want to know how many hours she worked, we need £185.50 divided by £53. So 185.50 divided by 53, and we get 3.5 hours, or 3.5 hours. And we can put that on our answer line down here. 8b. The company uses this formula to work out the charge for a job. The charge equals £45 plus £28 per hour the job takes. The job will take 11 hours. Will the charge be less than £350? You must show you're working. Well, let's put the numbers in. So it's going to be £45 plus £28 per hour. So 28, and there's 11 hours, so 28 times 11. And we're going to do this bit first. We can put brackets around that to show we're going to work this out separately. In fact, if we do 28 times 11, we get that this bit is 308. So in other words, we want 45 plus 308, which gives us £353. Now they've asked, will the charge be less than £350? Well, we can say 353 is greater than 350. So, no. And 8c. The diagram shows how much petrol is in the tank of Kim's van. Okay, so you can see this is full, this is half full, this is empty, so looks like it's a quarter there. Kim takes the van to the petrol station to fill the tank. The tank holds 64 litres when full. Petrol costs £1.45 per litre. Kim has £70 to pay for the petrol. Does she have enough money to fill the tank with petrol? You must show you're working. Okay, so she's already got a quarter of a tank. She wants the rest. So that means the bit she needs to fill up must be 3/4. So she wants 3/4 of, or times, 64 litres. So 3/4 times 64 gives us 48 litres. That's how much petrol she needs. It costs £1.45 a litre. So we're going to multiply that by £1.45. I'll make that a curly L so we can see it's the litres and not 481. So 48 times £1.45 gives us 69.6, but because it's money, we're going to make that £69.60. That is less than £70. So does she have enough money? Yes, and she's got 40p left to buy I don't know, a chocolate bar. If you can buy a chocolate bar in a petrol station, probably not for 40p. Question 9. Cycling. Talik likes cycling. 9a. Talik wants to buy a new bike. There are two ways he can pay for the bike. Okay, so we've got the road bike there. We've got option 1, we've got a cash price of £570. Or option 2, pay 10% of the cash price and 12 monthly payments, or 12 payments of £45.75. Talik says, if I use option 1 rather than option 2, I will save more than £35. Is he correct? Well, we know the cost of option 1 because it's just the cash price. So we need to work out the cost of option 2. So pay 10% of the cash price. Well, to the 10%, well, we can do 10 over 100, or we can just knock the 0 off. So it's going to be £57. And then 12 payments of £45.75 gives us £549. So in total, we get £606. So how much will he save if he bought option 1? Well, we want the difference, so we want 606 minus 570, which is £36, which is indeed more than £35. So is he correct? Yes, it is. (9b). Talik finds information about the number of students who cycle to his school. In total, 115 students cycle to school. The bar chart shows the information for some of the year groups. The information for year 7 and year 11 is missing. So let's have a look here. Okay, number of students, so we've got for year 8, 9 and 10, but nothing for year 7 and year 11. Twice as many year 11 students as year 7 students cycle to school. Complete the bar chart. So we've got to work out how many we got in 7 and 11. Well, we can start off by working out how many cycled in year 8, 9 and 10. Well, year 8, we've got, this is 20, and we can see each of these little boxes equals 1, because that would be 21, 22, 23, 24, 25. So this must be 21. Year 9, that's 30, that's a nice straightforward one. And year 10, well, that's here, so that's 26, 27, 28. So if we add up year 8, year 9 and year 10, so we do 21 plus 30 plus 28, we get 79. So that means that year 7 and year 11 must be the 115 students we started with. That's the total. So it's going to be 115 minus 79. Which gives us 36. Okay, so we know that year 7 plus year 11 equals 36. Now, twice as many year 11 students as year 7 students cycle to to school. So if we think of that as like a ratio table, we can think twice as many year 7s. Twice as many year 11 students as year 7. So if we put year 7 and year 11, twice as many. So that means for every one year 7, we've got 2 Year 11s. Now, if we just had, let's give ourselves a total column. If we just had 1 Year 7 and 2 Year 11s, that would be 3 in total. We've actually got a total of 36 Year 7s and 11s altogether. So we've got to think, well, how do we get from 3 to 36? Work backwards. Let's do 36 divided by 3. So it's 12 times bigger, this. So we need to multiply 1 times 12, which is just going to be 12, and 2 times 12, which is 24. So now we can mark our bars on the chart. So we want 12 Year 7 students. So here's 10, so 11, 12. Colour that one in. And we've got 24 Year 11 students. So 20, 21, 22, 23, 24 would be there. Let's read that one across. And then draw our bar. Make sure you're using a ruler to draw it. You don't have to colour it in, but I'm just doing it to make it a bit clearer. And there we go. Bar chart complete. Question 10. Wedding. Linda is planning a wedding. 10A. Linda is planning where to place the tables for the wedding meal. All the tables are rectangular. She wants a gap of at least 1 metre all around each table. One main table measuring 5 metres by 1 metre. So 5 metres by 1 metre. 2 guest tables, each measuring 2 metres by 1 metre. So 2 metres by 1 metre. And we've got 2 of these. 1 cake table measuring 1 metre by 0.5 metres. And we're told the grid below is a scale drawing of the room. Use the grid to draw and label a possible plan for the tables. And we're told the scale is that 1 square, so one of these squares, represents a 0.5 metre by 0.5 metres square. So that means that that's 0.5 metres and that's 0.5 metres. So what we can do is we can use that to work out, well, how many squares on here do we need for each of our tables as a starting point. So we need to do 5 metres divided by 0.5, and that's going to tell us how many squares. So that's going to be 10. So that's 10 squares. I'll put square. And 1 metre. So 1 divided by 0.5. That's going to be 2 squares. Okay, so actually maybe if we do it on this side. So we're going to have 10 by 2. These are for the squares. We've got 2 metres and 1 metre. So 2 divided by 0.5. That means we're going to have a table that's 4 squares. And we saw that 1 divided by 0.5 is 2. So all in squares. And we've got 2 of these tables that are 4 by 2. And then we've got the cake table, which is 1 metre by 0.5 metres. Well, we know the 0.5, well, that's just going to be 1 square, because 1 square is 0.5. And 1 metre, well, 1 divided by 0.5 gives us 2. Right, so we've got to draw these on our grid here. We want a gap of at least 1 metre all around each table. So that means we can't have any tables right up against the walls. So we need at least 1 metre. Well, 1 metre 1 divided by 0.5 meters is 2 squares. So in other words, we can't have anything in this space. 1, 2 squares here. Can't have anything in this space here. Nothing in that space. And we can't have anything there. But now we can start to put our tables in. So the main table, 10 squares by 2 squares. Well, let's start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And go down 2. 1, 2. Now, if you want to make sure your table is perfectly central, then you can do that. But I'm just going to make sure it fits. So this is our main table. Now we've got to have a 1 meter space all the way around it. So remember, 1 meter is 2 squares. So we can't have anything in this space. If we go 1, 2 squares, that means we can't have anything in this space either. Then we can have a guest table, 4 squares by 2 squares. So let's move it up. So we start here, 1, 2, 3, 4, 1, 2. And we need 2 of these guest tables. So this can be guest table 1. But then we've got this space of 1, 2 squares. And 2 squares in this direction. So that's got to all be left empty. But we can put another table starting here. So 1, 2 down, 1, 2, 3, 4 across. So this can be our guest table 2. And then we need our space of 2 boxes, or 1 meter this side and 1 meter down here. Leave that blank. Now all we've got left is our cake table, which is 2 squares by 1 square. So let's put that right down here at the bottom. So 1 square up, 2 squares across. Cake. There we go. It doesn't have to be exactly the same as mine. But so long as you've got these no-go areas, and I find it helpful to scribble in them because then it's clear you can't put anything else in those spaces. (10b). Linda is making a bouquet of flowers for the bride. She will use pink roses and cream roses in the ratio pink to cream equals 1 to 3. Linda will put 5 pink roses in the bouquet. She has 21 cream roses. How many cream roses will she have left after making the bouquet? You must show your working. Now I might have said bouquet and bouquet, and it's up to you how you want to pronounce the word. The important thing is it means a bunch of flowers. So we've got our ratio here. We've got pink, we've got cream, and let's have a total. So we draw in our ratio table. And we've got 1 pink for every 3 cream. So if that's all we had, we would have 4 in total. Okay. What have we got? She'll put 5 pink roses in the bouquet. She has 21 cream roses. How many cream will she have left over? So if we've got 5 pink ones here, we can say, well, to get from this row to this row, well, we just multiply by 5 because it's 1 to 5. So we need to have the same ratio for the cream ones. So we also need to multiply the 3 by 5. Okay, there are 3 lots of these, so we need 3 lots of 5. So 3 times 5 means that there must be 15 cream roses. Well, we're only worried about the cream roses. She's got 21. We're only using 15. So how many are going to be left over? It's going to be 6. Now, I did do a total column. Turns out we don't actually need the total because we're just worried about the pink and cream. Okay, but there's no harm having a total column. Often we're going to need that, but I can just put my 6 on the answer line. Question 10C. Linda is baking the wedding cake. She finds this recipe for a cake to serve 20 people. Wedding cake serves 20, 200 grams of flour, 850 grams of dried fruit, 180 grams of butter, 180 grams of sugar, and 6 eggs. Linda wants to make enough cake for 30 people. Make sure we can fit it all in. There you go. She has plenty of flour, sugar, and eggs. She has 1 kilogram of dried fruit, 140 grams of butter. Work out how much more dried fruit and butter she needs. Okay, so we don't need to worry about the flour or the sugar or the eggs. There's fruit and butter. So this serves 20 people. We want to know how much we need for 30. So what we can do is we can think, well, if we divide it by 20, that would tell us how much we'd need for one person. Then if we multiply it by 30, tell us how much we need for 30 people. So 850 divided by 20 times 30. And we get 1,275 grams. We can do the same with the butter. Divide it by 20 and then multiply it by 30. And we get 270 grams. Right, so we've got 1 kilogram of dried fruit. Well, that's 1,000 grams. So if we want to know how much more we need, well, it's the 1,275 minus the 1,000 she's got. Which will be 275 grams. Now let's do the same with butter. Well, she needs, oh, not equals, she needs 270. She's already got 140. So 270 minus 140 means we need another 130 grams. So we can put these down on our answer lines here. 275 grams for dried fruit and 130 grams for butter. Question 11, school playground. Steve works as a caretaker in a primary school. I'm going to move this up so that we can get the whole question on. 11A, Steve wants to buy a climbing frame for the school playground. Pupils in years 4, 5 and 6 have been fundraising to pay for it. The climbing frame will cost £950. The table shows how much money they've raised so far. Okay, so year 4 have raised £325, year 5 have raised £234 and year 6 have raised £282. The teachers help by baking and selling cakes. They sell 62 cakes for £1.20 each. All the money from selling the cakes is added to the fundraising total. How much more money do they need to raise to buy the climbing frame? Well, let's see how much they've raised so far. So 325 plus 234 plus 282 gives us £841. How much did they get from the cakes? Well, it's going to be 62 cakes at £1.20 each. Which is £74.40. So if we add these two together, we get 915.4. It's money, so we need to make that £40. So if we want to know how much more they need, it's just going to be our 950 minus the £915.40 that they've already raised. I'm going to put that in my memory, so we can say 950 minus memory recall gives us 34.6 or £34.60p. (11b). Steve built a new sand pit for the school playground. The sand pit is in the shape of a cuboid. And we've got our cuboid sketch there. Steve needs to buy bags of sand to fill the sand pit to the top. Each bag contains 0.05 metres cubed of sand. How many bags of sand does Steve need to buy? You must show your working. Well, we want to know the total space of this, so in other words, the volume, and the volume is the length times the width times the height. So it's going to be 1.5 times 0.7 times 0.3. Okay, so we get 0.315, and that's meters cubed. Okay, now each bag contains 0.05, so we need 0.315 divided by 0.05 to tell us how many bags we need. So we've got 0.315, we're going to divide that by 0.05, and we get 6.3 bags. But you can't buy 6.3 bags because they're going to sell them in whole bags. So we have to go up to the next whole number, so needs 7 bags. Seven bags. And finally, 11c. Steve is going to replace the fence panels around the playground. Here is a plan view of the playground. Let's move this up here. Okay. So we've got the measurements around it, and we've got a gate here. Steve will keep the old gate and buy new fence panels, so we don't have to buy anything for here. Fence panels are 2 metres wide. Each 2 metre panel costs £32.46p. Steve says the total cost of the fence panels will be less than £1,600. Is he correct? Okay, well, let's work out the cost and then we can compare it. So we want to add up or work out the perimeter basically without the gate, and then we can work out how many panels we're going to need, and then we can work out the total cost. So if we're starting here, we're going to have 10 plus 28 going across, then plus 22, then plus another 28, and finally plus 10. So 10 plus 28 plus 22 plus 28 plus 10, and that gives us 98 metres. Now the panels are 2 metres wide, so 98 divided by 2 will tell us how many panels we need. 98 divided by 2, 49 panels, and they cost £32.46 each, so multiply that by 32.46, and we get £1,590.54p. Steve says the total cost of the fence panels will be less than £1,600, and we can say, well, that is less than £1,600. So, yes, he is correct. And that's the end of the paper. So, hope you found it helpful. Please like the video, subscribe to the channel, turn your notifications on to find out when I add more videos, and I look forward to seeing you again soon. Thank you.